Okay. So, for the midpoint approximation, like I said, we're going to keep everything the same as yesterday. So we should be sketching the same equation. And we're going to keep it in the same interval. So 0 to 2. And really it's 0 to 2 because that's where the graph hits the axis. And we're using 4 subintervals. And we're doing this midpoint approximation. So let's see, our graph would look like this: 1, 2, 3, 4. And we're going to go over 1, down 1, and then down here. So just like yesterday, guys, we have to divide this x-axis into the 4 subintervals. So where do those get divided? At all the halves. Good. So 1/2, 1, 3 and a half, whatever, 3 halves, and 2. Okay. So this is starting out very much like yesterday. All right. So if a left-hand approximation is going to the left side of the picture and starting, and a right-hand approximation is going to the right hand of each little subinterval, then how are we going to do a midpoint approximation? Go to the middle. And not just the middle of this picture, not just here, but the middle of each subinterval. So we need to go to the middle of this little area here. We need to go to the middle of this one, the middle of this one, and the middle of this one. So your picture ends up being broken into even more pieces than it was before. Because if we're in the middle of this subinterval, what x value am I at? Good. I am at 1/4. So you're going to have to kind of put tick marks now for all the fourths in between, and that's how we're going to draw our rectangles, okay? So I'm going to draw the first one and talk through it pretty slow, and then you can finish it out. But a lot of people struggled with this one this morning. Not the dissecting the x-axis, they were okay with marking every quarter, but actually drawing it was an issue. So how do we draw it? Well, I know that a rectangle exists between 0 and 1/2. So I go between those two to 1/4, and at that 1/4 mark, I need to go all the way up to where that hits the curve, okay? And wherever that hits the curve, that's where I draw the top of my rectangle, okay? So the top of my rectangle, I'm going to go over to 0, and then I need to go over to the 1/2, okay? I'm not going to keep going like all the way over to this one. I've got to stop between 0 and 1/2 right here, because I still have to draw 4 of these. And then I'll come down, so then I'll finish that one off like that. Okay, so there's my first rectangle. So when I go to draw my second rectangle, what x value do I need to start at? Good. Between the 1/2 and the 1, which is what? 3/4. So for this one, I'm going in between these two, which is the x value of 3/4, and I'm going to go all the way up to where that hits the curve, put a dot there, and that's the top of that rectangle. And then I come back down. Okay, I'm going to stop and let you try to do the next two. And then we'll talk about the actual area of each little piece. So just take a minute and try those yourself. So before we actually find the area, in terms of comparing this to left hand and right hand, what do you think? Better, worse? Okay, so the point is to say, are we going to be closer to the real area, or is it not as good as one of those other two? And you're saying worse.
No, I said more accurate.
My bad. You said closer, and that's kind of what I think too.
Decide after we actually do something.
We can. We can decide after we start doing area. I do want to shade before I do area because some people still don't see what we're trying to compare. But we want the area under this entire parabola, but look at what happens with each rectangle. Each rectangle has a little bit that's below the curve.
Oh, but then it balances really quick.
Yes, sir. Good job. Then it does. It balances with a little bit above the curve on the other side. So since you're balancing each little piece out, then it just becomes a game of comparing how much less it is to how much greater it is in each little triangle. And we should know by this picture, we should know if it's going to be an under approximation or an over approximation. So can you compare the gold and the black? What do you think that this is going to be? This is going to be good. I think so too. I mean, I don't know yet either. We haven't done the math, but I think it's going to be an over approximation because the yellow areas are larger than the areas underneath. So it should kind of win, but just by a little, okay? So how do we do? Now the same as yesterday. It's a rectangle. We're going to do length times width for each one of these. Well, what's the width of the first rectangle?
It's like 1/2.
It's 1/2, just like yesterday. The width is 1/2 on all four of these, okay? So the width is 1/2, and we need to know what the length is, or the height, however you want to think about that. And the height needs to be this point right here. So how do I find that point right there? Excellent. Plug 1/4 into the equation. Why 1/4?
That's where you started.
Good. That's where we started on the x-axis. That's how we drew that point, was going to 1/4 and up. So I'm going to write it like this. I know I didn't do this yesterday, but this is a little math notation before we actually plug it in. And you know what? I'm going to split this up so we're not all having to do crazy fractions, okay? So for now, we know the first rectangle is 1/2 times f of 1/4. Now the second rectangle, the one that's in red, okay, what's the width on that one? And now the length or height on that one is, where were we when we drew up to the curve?
3/4.
Where we're at f of 3/4. So that's what we're going to find for that. The next one I haven't labeled on here, but maybe y'all labeled it on your graph paper. Of course, it's 1/2 here, but we need to know that y value there, which is what? Yeah, very good. F of 5/4. Okay. And so the last one, if you haven't guessed it already, just looking at our pattern, it's going to be 1/2 times f of what? 7/4. So we're gonna split this up because this is not a lot of fun to do all this fraction math by yourself with your calculator. So, so let's do, this table gets 1/4, that table gets 3/4, f of 3/4. Girls back there, 5/4, and you choose guys, 7/4. And remember, this is our equation. So let's plug and chug, and then we'll start filling this stuff in, okay? So go for it. Okay, so once you go and plug all of these back into the original equation, the answers in pink are what we have. And to finish it out, you just fraction math your way to the end. So the first one, you're just going to have 63, 30 seconds, and then 55, 30 seconds, and then 39, 30 seconds, and 15, 30 seconds. And adding all those together, who's got the calculator? Riley, you're on it? She's on it. Okay, as soon as you get it, let me know what the final is, please. 172, 30 seconds. Now, what is that as a decimal? Because we know the real answer is 5 1/3. We just don't know how to get it yet. But let's see how close it is. 5, 4, 3, 7, 5. Ooh. So this is even closer than gross. I apologize to the viewers out there. Sorry. Stop it! I knew you were going to do that. Stop. The 5.375. This is even closer than yesterday, whenever y'all took the two that we did yesterday and averaged those together. This one's actually even closer than that. So this is better than just averaging and doing the other two. Yay. And it turned out to be an over approximation. Is that what we had guessed by looking at our shading? We sure did. Go us. Okay, so that's midpoint approximation. Any questions on this? Or anything you want me to clarify on this?
What it means, like, F was before you plug in with just.
F of anything is the plug back in phase. You got it. And for a shortcut, okay, you ready for a shortcut? Shortcut. Did anybody think as we were going through all this, that 1/2 is just a nuisance? We could have totally factored that out at the very beginning because every single term has a 1/2. And to make our fraction math a little easier, we could have just had 1/2 times all the F ofs. F of this, F of that, F of that, F of that, you know, and then it would have made it a little quicker, just kind of saying at the end. So, you know, be thinking about that because the width never changes on any of these. So feel free to factor that out at the beginning. Save yourself a little headache. It's only a step, but you know, it's a step. It's a step. It's a second of your life back. Okay, I got some